All right, we're going to move into the most difficult part of this class, and that is looping. Looping isn't that difficult once you understand it, but it does. There is a learning curve to that, and that's what this lesson is going to be to start you out to understand what looping is all about. So there's some terms that we're going to have to think about and learn, and how they all fit together. So a loop simply is a way for our code to keep going around and around and around until we want it to stop. So in the past, when we have a person wanting to order something, the problem statement would always be, oh, only one customer, only one order, and that's it. You know that software doesn't really work that way. If a person wants purchasing software, they want to know how much was purchased all day, and what's the average purchase, and when was what times were the most purchases. They want a lot of information from that application. So the application can't just run once with one customer and then drop dead. It has to keep on running. And that's what a loop is, or sometimes you'll hear it as an iteration. And that just means that things keep going around and around. So what are the pieces parts to a loop? Well, one of the first things we need to have is something called initialize the loop. So in this case, I'm going to use the variable let's loop, and I'm going to set it to yes. So remember, we used to have error flag equals 1 and 0. It's the same kind of principle, and that is when we do a loop, in order for us to be able to start the loop, something has to be true. And we normally make that true thing with an assignment. And then if we want to stop the loop, we have to change this yes that's stored inside let's loop to no. So this is the first part, initialization. And then we'll go ahead and add the loop structure. Now you can see we have a for loop, a while loop, an exit loop. We will not be using the for loop. We will not be using the exit loop. The only thing we'll be using is a while loop. Just for your information, the difference between a while loop and a for loop, in general, we use while loops to input information because most of the time we don't know how much information is coming in. We use the for loop for output of information because when we get all the stuff in, well, we know how much stuff we have, and then we can use the for loop to push it back out again. That probably doesn't make any sense to you. Just to let you know, that's once you start doing programming, when you get into a course that has a for loop, you'll see, oh, I see now, yeah. We use while to bring it in, and because we don't know how many is coming in, and we use a for loop to get it out because we know how much stuff we have to get out. So there you go. So we're always going to be using this while loop. And this is what's going to look like on your screen. It's going to have a true and a false. If this expression is true, we go around. And it stays true, we keep on going around. And then once it's no longer true, then it's false and we drop out of the loop. So I always tell students there's three most important things that you want to do. And there's how do I get into the loop? How do I stay in the loop? And how do I know I'm out of the loop? Or actually, how do I get in the loop? How do I get out of the loop? And how do I know I'm out of the loop? So how we get in the loop is this let's loop. So that's a variable, Control C. So we're going to copy that. And then my expression is going to be the same thing as this. Let's loop equals yes. And that's not an equal sign. And that's not either. Home row. So you can see that these two things are the same, and that's because, well, I want to pull it. What's the point of my application if I'm not going to go into the loop, right? So this is true. It evaluates it again. So first it puts yes into here. Now it sends these to the central process unit. It says, yes, they're both the same. So it's true. We step into the loop. Now, once we get into the loop, so let me just do an output. I'm in the loop. And then, so that's how I'm going to get into the loop. How am I going to get out of the loop? Well, we'll do that well, let's just go ahead and do it. We have to use that same place in memory for getting out. So we're going to put an input here, and that input is going to be Control V. Let's loop, and the question is, do you want to keep looping? And again, that's in quotes. If they say yes, that stays yes, and it's true, so we keep on going around. Once they say no, then it's false, and it goes out. Now the thing is, let's go ahead and run this first and see how it works. I'm in the loop. See, so that popped up because we came in here. This is the same. It's true. Put that out of the wall. Come on now. There we go. So this is true. So it goes in here. This pops up, so we know that we're in. When I click OK, it's going to ask me the question, do you want to keep looping? I say yes. And it comes back and says, I'm in the loop. So once again, we came around a second time. Want to keep looping? I say no. And nothing happens. And this is why I always tell students, you want to have one more thing. How do I get in? How do I get out? And how do I know I'm out? Now, when we do the build and test methodology, we may not need to have this output because we're going to know with other output, but done looping. For simple problems, you always need to know whether you're out or not, because sometimes when you hit the play button, this thing might keep on going around and around and around and around. You think it's done, but it's not. It's circling. So we use this done looping. You'll see that in the future, this will be your favorite output, because if we don't get done looping, that means that we are trapped in a loop. And how do we get trapped in a loop? Well, let's see, I'll move this out to here. Now when I run it, I'm in the loop, I'm in the loop, I'm in the loop. See, it just never stops. That's an infinite loop. And that's because I got into the loop, but I have no way of getting out of it, which means I'm trapped in there forever. It's called locked in an infinite loop, and you never want to be there. All right, so this is the basic loop structure. And so what do we want to do in our loop? Well, one of the things that we want to do is we'd like to count how many times we go around that loop. So say if this was an ordering processing system, every time we went around a loop, that would be another customer. So when we do that, we use something called a counter. So, and when we create counters, we use a suffix of count to let us know that this is what it is. It's a counter. And counters are always the same. It's whatever you want to count equals whatever you want to count. So that'd be loop count plus 1. So we're going to add 1 to loop count each time we go around, and that's why it's called a counter. And let's see how that works. So I don't need this I'm in a loop anymore. Let's change this to number of times in the loop, number of times around the loop. How about that? And we'll join this with loop count. All right, now let's go ahead and run it and see what happens. Number of times around the loop is 1 because we're in the first time. Then I say yes. Now it's 2. All right, so I've gone around twice. I've gone in one time, and now I'm around the second time. I say yes. Now I have a loop count of 3. And then I say no. And I'm done looping, and I'm out. So that's a counter. That's an important thing to remember. So every time you want to count each time that you go down, go around the loop, or every time we go down a path, because we may have several counters. If we say that if this is true, count this, else count this, else count that, we might have more than one counter. So we use whatever we're counting equals whatever we're counting plus 1. Here, we're just counting loops. So that's what it is. The last thing I want to do before we leave, so this goes too long, is I'm going to add an input Stuff in loop. So that's called stuff in loop. So I'm going to copy that. And I'm going to say how much stuff. And now I'm going to have to use a count, not a counter, but an accumulator to accumulate the stuff in the loop. So accumulators, we call this, we use the suffix of accum. So stuff accum equals stuff accum plus stuff in loop. And now I need another output. So I'm going to go ahead and copy this, paste it here. Number of stuff and then this here will be, no, that won't be stuff in loop, it'll be stuff accum. We want to see what's in that accumulator as we go around. All right, so now let's go ahead and run through it again. How much stuff? Let's just say there's 10. One time in the loop, there's 10 things of stuff. If you want to go around again, and we say yes. And now what's the next thing? And well, let's just go say 20 this time. So we had 10 before, now we have 20. So now we have a second loop because we added one to the loop count. And now we have 30. 10 plus 20 equals 30. Let's go around one more time for grins. Yes. And this time I'll do 30. And this is the third time around the loop. And now we have 30 plus 30 is 60. 60 stuff. All right. And then when I click OK and I type in no, I'm done looping. So this is the basics of loops. How do we get in? How do I get out? How do I know I'm out in order to get the basic loop structure? And then once we're in and using loops, we have two pieces of technology that's very important. And that is a counter that counts how many times we've gone down a certain path in a loop, and an accumulator, which simply accumulates values each time it goes around the loop. Basically, they're the same, except this one increments by 1 and this increments by a variable number. But we use the count suffix and the accum suffix. So when a person takes a look at our code, they know exactly why we're doing that code. Ah, there's a counter. Oh, I see what they're doing here. They're accumulating here. All right, and that's it for this, and we'll move on to the next thing, which is coding.